The sun, the giver of life, burns most intensely at the equator. It powers a rich zone of life that traverses 3 continents, 3 oceans. More than a line on a map, Equator is a vital force of nature. Every second, our sun explodes thousands of trillions of hydrogen bombs. The energy gives life to our small planet, and much of it is absorbed in the region of the equator. The sun is a protector, a nurturer of new life. More than half of all animals and plants on Earth live in the zone of the equator. Life here is extraordinarily rich, wonderfully diverse. But the sun can also be a tyrant. It pushes climate to extremes, causing starvation and death. But life around the equator has found ways to triumph over the sun's brutality. At the equator, a new day arrives at staggering speed. Dawn sweeps westward at 500 meters per second. The coming of the sun to Southeast Asia ends 12 hours of darkness. And 12 hours of a new day suddenly begins on the island of Borneo. In Borneo, the sound of dawn is deafening. Gibbons sing to claim territory or as an invitation to mates. Their choruses can be heard over 2 kilometers away. In this rainforest, you must sing loudly to be heard. A male orangutan is a late riser. He joins a mass choir that's been greeting the sun for millions of years in this ancient rainforest. In these forests, the trees control the lives of animals. They make it difficult getting from one place to another. In order to find breakfast, gibbons must perform death-defying leaps. Gibbons are the finest aerial acrobats of all apes, but getting from tree to tree can be a leap of faith. Travel is difficult because the biggest trees have few side branches, which creates wide gaps. To cross these aerial canyons, animals have become inventive. Draco lizards are one of the many that glide across the gaps. But the best of all gliders is a mammal, the beluga. And if danger threatens, they can soar 120 meters. Gliding is a popular means of travel, though some animals are not built for it. Orangutans can't glide or leap. Instead, they pole vault. They bend saplings like Olympic athletes and swing. It's no stretch of the imagination to say that the trees of Southeast Asia control the animals. And the biggest trees, the dipterocarps, exert most control. Much of the sun's energy is stolen by their great umbrella-like crowns. Everything literally lives in their shadow. As the morning sun ascends higher, the giant dipterocarps take first helping of its energy. Lower down, sunlight is filtered through layers of foliage. At mid-forest height are more than 1,000 orchids, many so sensitive, a tiny drop in temperature may kill them. But this orchid is not what it seems. It's a flower mantis, and it's sizing up a meal. Mimicry is most useful in helping this predator catch some of the 1,000 different insects that may live on this tree. And deeper in the shade are trees bearing many different fruits. Star apples, mangosteens, lychees, figs, rambutans, all use sweetness to seduce. In return, the diners spread the seeds of the tree. Durian, the king of fruit, has a narcotic-like attraction to many animals, but its riches are well protected. Durian has met its match, gone in a single bite. Asian elephants also fancy jackfruit, but they too have armored protection, and accessing them requires a weighty solution. Seeds of sweet jackfruit will later be sown far away from here. And so, even the most powerful animal in the forest becomes a servant of the trees. Trees are worshippers of the sun. The sun's gift is a spectrum of light waves, some visible, some invisible, and the dipterocarps absorb most of them. Below, smaller trees take what's left over, until down on the forest floor there's almost nothing left. Plants here live in a twilight zone, where they must make do with less than 1% of full sunlight. Yet occasionally, they must face the sun's full fury, when it beams down through tiny gaps in the leaves. Capturing the sun's energy isn't a problem for Rafflesia. Its flowers are the largest in the world and the most repulsive. Its petals resemble putrefying flesh, and it generates a foul odor and emits heat. The total effect is designed to mimic a rotting corpse, making Rafflesia irresistible to the flies that pollinate it. But how does it get the energy for such lavish displays? A clue is this long, narrow stem. The giant flower has neither leaves nor roots of its own. Instead, Rafflesia is connected to a nearby vine. It's a parasite, and its thin filaments suck energy from its host vine. The vine grows up into the treetops, where its leaves soak up the full energy of the noonday sun. Noon at the equator. The sun is at its closest to our planet. At midday, shadows are at a minimum. Energy is at a maximum. The heat is overpowering. A rhinoceros finds some relief in a wallow. A mud pack prevents overheating. Heat has become the enemy. Animals don't hunt, they rest. But the sun offers no rest to the trees. In fact, they work so hard through the middle of the day that by mid-afternoon, they can help change the weather. Billions of leaves busily harness the sun's energy to make food from carbon dioxide and water. Each day, a single tree draws thousands of liters of water up through its roots and into the trunk. A network of thin tubes moves water against gravity maybe 80 meters up to where it's needed in the leaves. But in the green miracle of photosynthesis, water is also a byproduct. What the tree doesn't need is pumped out as vapor. Vapor builds up until there is so much of it above the forest, it forms clouds. By mid-afternoon, the clouds have gathered so much vapor, they are ready to burst. These daily showers come mainly from the joint efforts of the forest trees and the equatorial sun. Each year, 5 meters of rain falls in these forests of the sun. End of day at the equator comes just as quickly as the arrival of dawn. Silvered leaf monkeys descend to take a late supper. But dusk is a dangerous time. Mouse deer are watchful, and the monkeys post a lookout. They dine on grasses and shoots that they will digest slowly overnight. But the tiger prefers to dine on the diners. Tonight, a leaf monkey will fill the tiger's stomach. The lives of predators and prey are ruled by the trees of these forests of the sun. But there's one place on the equator where there are no trees. And without trees, the sun turns up the heat of battle between predator and prey. Moving west across the Indian Ocean, the equator is clearly seen as a zone of cloud. Clouds form over the ocean as the sun raises water temperature, causing massive evaporation. Every day, evaporating water causes cloud to build up until they become thick and heavy with water. This cloud is a feature of many parts of the equator. But closer to the coast of Africa, equatorial cloud disappears. And without cloud, there can be no rain in East Africa. For much of the year, the African savanna is punished by heat and drought. When rain comes, it's vitally linked to animal survival. The sun tips the balance of equatorial forces, and animals must use whatever means to stay alive. Vultures ride on rising spirals of heat. They are the savanna's messengers of death. During the drought, lions are not too proud to steal from the vultures. Survivors seize any opportunity. Hunger stalks the land. The lion's hunting grounds are depleted. Mothers have little milk, and their cubs are weak. Adult lions must eat at least 20 kilograms of meat a week. Any less, they and their young will be in peril. In the dry season, many cubs will starve. Hyenas are starving, and they are cub killers. The sun pits animal against animal. Resources are stretched. Few animals remain on the savanna throughout the dry season, but that is about to change. In November, the sun draws the Asian monsoon toward Africa. At first there is only cloud and winds. But winds bring the promise of a change of season and are the trigger for a mass migration. Millions of animals now embark on a journey of opportunity. They may travel several hundred kilometers with instinct as their only guide. As they approach the dry savanna, so do heavy rain clouds. The arrival of the wet season is sudden and dramatic. Every day it pours for less than an hour and then stops. This pattern will repeat for weeks. The rains come near the hottest time of year. The sun that parched the land for months on end now brings water to quench its deep thirst and to create a miracle. The sudden change to green abundance is why the herds have made their long journey. Freshly sprouted grasses are feasted on by close to 2 million wildebeests, gazelles, and zebras. Parts of East Africa have the greatest aggregations of large animals on the planet. But Africa wasn't always like this. It was once an isolated island continent. It was unconnected to any other landmass and mostly covered in forest. Africa remained this way until 30 million years ago, when changes began to take place, changes that would have dramatic consequences in Equatorial Africa. East Africa began to be torn apart. Slowly, massive volcanic forces opened up a great valley. Over time, the Great Rift Valley spread from north to south for 5,000 kilometers. The Ethiopian highlands rose up, blocking rain-bearing clouds from the west. These changes, and the climatic changes that followed over millions of years, led to the gradual loss of forests and the slow spread of grasslands. The grasses that spread across East Africa needed to be drought and heat tolerant. But being close to the equator, the intense heat of the sun favored a special group of grasses called carbon-4, or C4 plants. In C4 grasses, the cells that make food by photosynthesis are packed tightly round sheath cells that concentrate carbon dioxide, which is its fuel. With more fuel, the leaf becomes like an engine with a turbocharger. C4 grasses grow rapidly, accelerated by the sun's heat. The whole system is encased in a tough outer layer, making these grasses very difficult to digest. But the new grasses could be eaten by an evolving group of animals. They are called ungulates, which means hoofed. They could digest these grasses because they had a secret weapon: multi-chambered stomachs. It was possibly on the grasslands of East Africa that ungulates evolved a new model of stomach that had an extra chamber called a rumen, which contained bacteria that could digest C4 grasses. It meant animals with super stomachs spread right across East Africa. There are close to 100 different antelopes in Africa, each one suited to a different way of life. But as antelopes evolved, so did their predators, especially the cats. And like their prey, the cats also became specialists. A leopard uses a treetop lookout to spy a meal. Silent as a shadow, it moves slowly into range. Others would steal the leopard's kill, so it seeks a safe place to dine, and the safest place is its home tree. To match the antelope's finely tuned sense of danger, the leopard has become a master of stealth. The cheetah has nowhere to hide. It's a cat of the open savanna. Out here, it must use a different hunting method. Exploding to reach speeds of 100 kilometers per hour, it's the fastest land animal in the world. Its body is streamlined. Its claws are spikes. It's light, flexible, and powerful. On these grasslands of the sun, there are many small, fast gazelles, and cheetahs use blinding speed to outrun them. Of all Africa's cats, the lion has been most shaped by the sun. Lions are the only big cats with an obvious social structure. They're also the biggest cats on the savannah. Males stand a meter high and weigh 200 kilograms, yet despite their size, they are on the margins of lion society. The male's job, apart from occasional babysitting, is to protect the pride and father the cubs. The hunting territory is passed from females to their daughters. The lion's size and unique social structure allows them to work in groups to hunt some of the largest grazing animals. But even working together does not guarantee success. Lions are often seen from a long distance, so most hunting is done after dark. Under cover of dark, lions can get much closer to their prey. But they hunt at night also because it's cooler. During the day, they overheat easily. The effort of bringing down large prey could kill them. Lions have developed their size and social structure to hunt large herbivores, and the strength to face one of the harshest environments at the equator, the dry season in East Africa. Further west, beyond the rain shadow, Congo, Zaire, Gabon retain some forests. And in these forests are animals unlike those on the dry plain. The okapi shares a common ancestor with the giraffe. In places, the forests form a patchwork with grassland, and helping sew up this patchwork are the farmers of the forest, Red River hogs. Red River hogs commute between forest and grassland. They spread seeds of trees and shrubs on the grass, helping to expand the forest. Forest elephants are half the size of their savanna relatives. They are rainforest creatures, and it rains a lot here. And in rivers and lakes all the way to the Atlantic, there are hippopotami. The sun is so powerful, they secrete a pink, oily sunscreen. Hippopotami also use water for sun protection and to support the weight of their thick-skinned bodies. Water may also have helped our African ancestors to walk upright. Where the jungles of West Africa open out into broad wetlands called bai, there are many succulent water plants. And West African lowland gorillas emerge to feed on them. These gorillas aren't keen on getting wet. But to get hold of these precious plants, some will conquer their dislike of water. With buoyancy to help it, the gorilla walks upright, with arms raised like a reluctant bather. Our African ancestors began walking on two legs near the equator. It's tempting to imagine that this is how we could have taken our first faltering steps. Evolution has taken bold strides all around the equator. The sun's energy fuels growth and fertility that runs through all life. In West Africa, the rivers run dark with nutrient riches that flow into the sea. The greatest of those rivers is the mighty Congo. And as it meets the ocean, the minerals spark a vast blooming of plankton. This explosion of tiny plants is fueled by the power of the sun. The plankton drifts westwards on an equatorial ocean current. But close to South America, an even bigger plankton plume spirals north on the warm Gulf Stream. This plume comes from the Amazon River. Its mouth is right on the equator. The Amazon is the mightiest river in the world. It has 1,000 tributaries that drain the greatest area of rainforest in the world. In Amazonia, the sun creates a year of two halves. An extreme wet season is followed by a long dry season. The dry favors animals like the jaguar. Its hunting grounds contain nearly a quarter of all the species on the planet. But the jaguar's kingdom changes suddenly. For half a year, parts of Amazonia are submerged. The flooded forests become a totally different environment, inhabited by more than 3,000 kinds of fish, or nearly a third of all freshwater species. This rich and diverse water world now becomes the realm of the giant otter. Giant otters are greedy predators, and they have to be to survive. An otter needs to eat 20% of its body weight of fish each day. They mainly eat one kind of fish, catfish. Half of all fish in Amazonia are catfish. That's over 1,000 species. They're found everywhere, from fast flows to backwaters. And their shapes are as varied as their lifestyles. Some catfish migrate in schools of millions. Others are large, slow and solitary. But whatever their size, they're nearly all on the otter's menu. And what an otter discards, others will devour. Piranhas also belong to a large family of over 30 species. But the red-bellied piranha is the most common and most notorious as a pack scavenger. Of the many fish predators in Amazonia, none is more impressive than the massive pirarucu. A fully mature pirarucu is 3 meters long and weighs 200 kilograms. It's one of the largest freshwater fish in the world, yet it can move like lightning. Victims are sucked in with a powerful rush of water. Pirarucu have survived in these rivers of the sun for 60 million years. They have adapted to change. They are well used to hardship, and hard times are coming to Amazonia. The growing season for water plants is coming to an end, and one plant eater is filling up while stocks last. The manatee or fish cow is related to the elephant, and it has an elephant-sized appetite. It eats 1/10 of its body weight each day. It feeds as if it won't eat again for months, which is true. During the dry season ahead, manatees will eat very little. The changing angle of the sun brings about a change in seasons and in fortune. It hasn't rained for some time, and water levels are lowering. Creatures now confront a new and even more difficult challenge. If you're adapted to wet, how do you survive the dry? As river waters lower, numerous lakes form in drying riverbeds, and this forces neighbors together. A family of giant otters has a holt or den on the edge of the lake. A caiman is attracted by the activity. Caiman won't bother adult otters, but there are young here. It drifts closer. Too close. With the caiman gone, it's now safe for the mother to bring the newest pups out of the den to play with their older brothers and sisters. Otters time their breeding to profit from the change of seasons. The otter pups will be big enough to hunt for themselves when the floods return, but that's still some way off. By September, the sun pushes the dry season into a critical phase. Many rivers have dried into stagnant pools that become fish traps. Warm water holds little oxygen, and all across Amazonia, fish begin to die. But amid the scenes of death and dying, there are survivors. The pirarucu uses an old trick to help it survive. It's one of very few fish that can take air directly from the atmosphere. Pirarucu can breathe. In fact, without air, it will soon drown. Long ago, its ancestor evolved a lung-like organ, which means it can absorb oxygen directly from the air. Pirarucu can survive in waters where other fish die. Death is everywhere, and so are vultures. The dry season has been too hot, too long. If only the rains had come earlier. In November, storm clouds gather over the Atlantic Ocean. They gather as the sun's intensity increases evaporation and winds blow clouds in towards Amazonia. As clouds pass over forests, they feed on water vapor from trees until they are saturated and it rains. Further west, clouds encounter the vast barrier of the Andes Mountains. But as the clouds rise over it, they release their water as rain or snow, which flows back into Amazonia. The great river network of the Amazon receives 20% of all available fresh water in the world. Amazonia covers most of the northern third of Latin America, and because it's almost perfectly flat, rivers fill faster than they can drain, and Amazonia slowly begins to flood. The sun triggers a rainy season that will last for half a year. The floods will completely transform the lives of the creatures here. Arowana are sleek hunters of small fish. But during the flood, they scan the world above for other prey. Arowana live in one world and hunt in another. At this time, they're better known as water monkeys. Strange creatures are on the move. And a sloth on the move much prefers to swim. The waters are safer during the flood. There are few enemies. This is the best time to travel to a new tree for food or a mate. It's been 2 months since the trees were submerged. Most trees die after just a few weeks of flooding. Their roots become waterlogged and starved of oxygen. But Amazonian trees can survive for half a year. In some species, a membrane forms on the outside of the root. Inside, partial cell death creates air holes that transfer oxygen and remove toxins. The trees have successfully adapted to flooding. But this extreme environment has also forced change on others. The floods are a trigger for many fish to begin breeding. This pair of Capella arnoldi moving together near the surface are about to lay their eggs. What's about to happen is a most remarkable spawning achievement. They leap together and attach to a leaf. They use their fins as suckers. And after a few seconds, the female, then the male, drop back, leaving behind a small cluster of eggs. This amazing effort is designed to protect their eggs from being eaten. They continue leaping until there are about 50 eggs. And although they're covered in gel, it's not protection enough against drying out in the hot sun. Keeping the eggs moist is the male's job, and it's a job at which he excels. As he smacks the water with his tail, it splashes up onto the leaf. He maintains this effort until the eggs hatch. The following day, the eggs have eyes. And a day later, they begin to hatch. The fries enter the river with the falling water droplets. In the river, the youngsters find hiding places among the leaves. They're now completely on their own. But some creatures of the flood have need of much greater parental care. In areas where the river flow is not too strong, the sun boosts the growth of water plants. And these plants are rapidly devoured by water cows. Manatees could find little to eat during the dry season. They now make up for it, and soon double their weight. This female has 2 mouths to feed. Her calf is a month old and weighs around 30 kilograms. It's growing fast on a diet of liquid sunshine. The sun has created a year of 2 halves in Amazonia. Animals must adapt to this changing rhythm, a rhythm that some of them know only too well. Piraricus have a family. Both parents care for their large brood of around 1,000. The young fish breathe air, just like their parents. As they feed, they come together as an orderly group, no one falling behind. They move as a wall of wide open mouths. Piraricus are ancient survivors and inheritors of these rivers of change. All around the 40,000 kilometers of the planet's equator, life must adapt to change or perish. But there are places where the power of the sun is blocked by opposing forces, and life must face even greater change and greater challenges.